So anyways, I was saying 1 magnesium on each side, 2 chlorines on each side, 2 fluorines on each side, so this one is balanced. I have 1 iron on the reactant side and 2 times 1 on the product side, so that one's not balanced. Let's do 7 together. And then you can do B and C on your own. So first you want to take an atom inventory. So you have calcium, chlorine. We don't have a lot of space, so we'll do lithium and then oxygen. On the reactant side, I have 1 calcium. On the product side, I also have 1. I have 2 chlorines on the reactant side, given that I have that subscript of 2. And on the product side, I only have 1, because I have no subscript with it, which means there's just 1. For lithium, on the reactant side, I have a subscript of 2, so that means I have 2. And on the product side, I have 1. And then I have 1 oxygen and 1 oxygen. So the atoms that aren't balanced are chlorine and lithium. I need more on the product side for each of them. So if I look, to get 2 chlorines, I would need to multiply the 1 chlorine by 2. So if I put a 2 coefficient in front of lithium chloride, that's actually 2 times 1 lithium and 2 times 1 chloride, which now that actually balances the equation. You can leave these spots blank, or you can put 1s in them if you don't like blank spaces, but that's up to you. I'll typically just leave them blank. Can you please pause the video and try B and C on your own? Welcome back. So you should have created an inventory with aluminum, sulfur, and copper. For aluminum on the reactant side, I have a subscript of 2, so that means I have 2. On the product side, I have no subscript, which means there's just 1. The reactant side for sulfur, there's 3. On the product side, there's 1. The reactant side, I have 1 copper. Product side, just 1. So to balance this, I can see that I would need to have a coefficient of 3 in front of the copper 2 sulfide, because that's 3 times 1 sulfur, which is 3. But copper is also part of that compound, so you do 3 times 1, which is also 3. So your sulfurs are balanced, but the copper and aluminum still are not. So what's nice is that the aluminum and copper are alone, so I can just put, I need 3 coppers on the reactant side, so I would do 3 times 1. On the product side, I need 2 aluminums. That's just 2 times 1, and now it's balanced. And here, I have sodium, phosphorus, magnesium, and bromine. 3 sodiums on the reactant side, 1 on the product side. 1 phosphorus on the reactant side, and I have a subscript of 2, so I have 2 phosphorus atoms. On the reactant side, I have 1 magnesium, and I have a subscript of 3 on the product side, so that's 3 magnesiums. On the reactant side, 2 bromines, and 1 bromine. So nothing is balanced. Okay, so you can kind of just pick. Right now, I'm going to start with magnesium. Okay, so I notice that I need a 3 here, because 3 times 1 magnesium is 3. Bromine's also in this compound, so I have to do 3 times 2, which is 6. I can then, if I want to just continue with bromine, put a 6 in front of sodium bromide to get 6 bromines, because that's 6 times 1. That also changes your sodium to be 6 times 1, which is 6. Which would mean I would need to put a 2 in front of sodium phosphide, to give me 6, so that's 2 times 3. It's also 2 times 1 phosphorus, which is 2, which worked out perfectly, because that's balanced. 8 gives you the answers. Now we're going to move on to balancing equations with polyatomic ions. Okay, so when an equation contains a polyatomic ion, it may look a little bit more difficult, but balancing an equation containing a polyatomic ion isn't much different than what you just did. In the equations above, you kept in mind that you balanced only one atom at a time. With polyatomic ions, keep in mind that you balance one polyatomic ion at a time. So for example, considering this unbalanced equation, sodium sulfate plus calcium phosphate gives you sodium phosphate, calcium sulfate. Now remember, when I talk polyatomic ion, that's an ion with multiple atoms. So SO4 is a polyatomic ion. Okay, as is PO4. So the first thing you should do is take note of which atoms or ions aren't balanced. Keep the polyatomic ion together. In other words, don't balance phosphorus and oxygen separately. Instead, balance phosphate ions on each side. So do you see how I kept phosphate as PO4 in my inventory? And additionally, I kept SO4. Okay, because I saw them on both sides, I was able to just keep them together. That way we're not separating it and having to add oxygens from multiple compounds. It's a lot simpler this way. Okay, but notice how I keep the inventory, right? So I had sodium, I have 2 sodiums and 3 sodiums because of the subscripts. Now notice how it says 1 sulfate on each side. Okay, you see how sulfate is SO4, right? It might look like there are 4 sulfates, but in fact there's just 1 SO4 on each side. I have 3 calciums on the reactant side and 1 on the product side. Now do you see how phosphate on the reactant side is in parentheses? That's when you know you have more than one of a polyatomic ion, when it's in parentheses and you have a subscript on the outside. What that tells me is I have 2 phosphates. And here it's not in parentheses, so I know it's just 1. I have 1 phosphate. So to balance, what I did was I put a 3 in front of the sodium sulfate, which gave me 6 sodiums, and 3 sulfates, not 12, just 3 SO4s. All right, and then I put a 2 here to balance the sodiums to give me 6, and that also gave me 2 phosphates. Then the last thing I would need to do is put a 2 in front of the Na3PO4 to balance the sodium and the phosphate. So which of the following equations are properly balanced? Why don't you try this on your own? Okay, welcome back. So here I have 1 barium on each side. I have 2 nitrates here, and I have 2 times 1 NO3 on this side, so that's 2 nitrates, 2 irons, 1 sulfate, and 1 sulfate. So this one's balanced. There might be multiple, so let's just check these out. I have 3 times 1 strontium, 3 times 1 strontium, 3 times 2 chlorines, which is 6. Oh, but I only have 3 chlorines on the product side. I have 3 calciums, 3 times 1, which is 3 calciums. I have 2 PO4s, and I have a 2 in front of a compound with 1 PO4, so that's 2 PO4s. Here I have 6 sodiums, 3 carbonates, and 3 carbonates, so C is balanced. 1 iron, 2 nitrates, 1 magnesium, 1 magnesium. So 3 of them were fine. Now let's go ahead and balance number 10. So first we have to take an inventory. So I have calcium. All right, so I have this polyatomic ion nitrate, NO3, and I see NO3 on the product side as well, so I can keep it as NO3 in my inventory. Notice how it's in parentheses with a 2 on the outside, so that means I have 2 nitrates. Sorry, I jumped ahead a little bit. I also have sodium. Okay, and then on the product side, notice how nitrate doesn't have parentheses, so I just have 1 NO3. Right, so it's not 3 NOs. So it's not 3 NOs, it's 1 NO3. I have 1 calcium on the reactant side, 1 calcium on the product side, 1 sodium on the reactant side, and 1 sodium on the product side. So the only thing that's not balanced are the nitrates for now, so I have to put a 2 in front of the NaNO3. That gives me 2 sodiums and 2 nitrates, because it's 2 times the 1 nitrate that I have. Then if I just put a 2 in front of the sodium, that becomes balanced. Now I have 1 calcium on each side, 2 nitrates, and 2 sodiums. Please try B and C on your own. Let me walk you through B and C after you've done them. So I have aluminum, and then I have carbonate on both sides, this CO3 ion. I have magnesium, and I have chlorine. I have 2 aluminums on the reactant side, 1 on the product side. I have 3 CO3s on the reactant side, and just 1 on the product side. 1 magnesium, 1 magnesium, 2 chlorines, 3 chlorines. So if I would like to, I can start off with balancing my aluminums. So I put a 2 here to do 2 times 1, which is 2. That also changes my chlorines to 6, because it's 2 times 3. That means if I put a 3 here, that's 3 magnesiums and 6 chlorines. And then on the product side, I'd put a 3 here because that's 3 times 1 magnesium and 3 times 1 carbonate, which gives me 3. And that's balanced. And again, you can just leave the first spot blank because it's just a 1, or you can write a 1 in there. For C, I have barium, and then I have phosphate on both sides. I also have carbonate on both sides. Okay, so I've got 2 different polyatomic ions here. So I'll keep it as PO4, sodium, and then my carbonate, CO3. I have a subscript of 3 with barium, so it's 3, and then just 1 on the product side. I have 2 PO4s. Again, it's the number on the outside of the parentheses that tells you how many polyatomic ions you have. On the product side, I just have 1 PO4 since it's not in parentheses with the number on the outside. I have 2 sodiums on the reactant side, 3 on the product side, 1 carbonate, and 1 carbonate. So if we want, we can start with the barium. We can put a 3 here. That's 3 times 1 barium. That also gives me 3 carbonates. If I want to try phosphate, I can put a 2 here, which will give me 6 sodiums, and then 2 phosphates. If I put a 3 there, that gives me 6 sodiums and 3 carbonates. And now I'm all balanced. 11's checking the answers. 12, I want you to try all of 12 on your own before you listen in. All right, so with 12, I have hydrogen, chlorine, magnesium. Okay, so I'm just looking at subscripts here, and that's how I got my inventory. So if I put a 2 in front of HCl, that actually did 2 times 1 hydrogen, 2 times 1 chlorine. Everything's balanced. You can leave the rest of those blank. Here I have sodium, sulfur, beryllium, and then I have hydroxide. So I have 2 hydroxides, 1 beryllium, 1 sulfur, 2 sodiums, 1 sodium, 1 sulfur, 1 beryllium, 1 hydroxide. So I'd put a 2 in front of the sodium hydroxide, and that balances everything. For the rest, I'm going to just show you the answers because I'm almost out of time. So the answers, you know what, I'll work them out actually, and then I'll just have a short video for the end. All right, so to start, I've got barium, chlorine, sodium, and I have nitrate, NO3. We'll pick this up in the next video.